Hello everyone, welcome back to Day One Dev channel. In our last video, we talked about streaming processing, about a product where we discussed about high level about Flink, Apache Storm, and Apache Spark. So as part of our today, I'm going to talk about some comparison metrics here when you're selecting one of these three major products which are available in the market, especially for stream processing, right? So let's start with our first comparison here, processing semantics. The Flink supports event time processing with the built-in supports of watermarks, allowing accurate processing based on event timestamps. It also offers exactly one semantic of a stateful operation, ensuring data consistency in the presence of a failure. And some of are well suited for application requiring precise event time processing, where data accuracy and consistency are crucial, especially in especially in our financial analytics systems. So strong processing events is in tuple-based models and providing at least one processing semantic, achieving exactly one semantic also may require additional efforts and coordination to ensure important processing is happening. And some of us scenarios here is same as Flink low latency, but it's a crucial in real-time processing and monitoring and alerting. Spark stream processing is pretty much in micro patches. It's slight delay to true stream processing, but it achieves fault tolerance through lineage information and recomputation of lost data, providing at least one semantic. So as we discussed in our previous video, where Spark is a pretty much a near real time. The keyword here is a near real time. It's not a real time. Uh, and integration within a broader Spark ecosystem. So now next one is easy of use and abstractions. Flink provides an unified programming model for both batch and stream processing with an high-level APIs. It offers pretty much a rich abstraction, making user-friendly for developers. Especially, it's easy for the documentation is easy to learn and create your development efforts. So, and it's ideal for, as we called out, programming model is easy to learn, and especially in applications where complex, you need event time processing. Okay. Storm uses, as we said, low-level spout bolt APIs, but it requires some manual effort for configuration and management. So it's also as a flexible as a, but it requires a lot of steeper learning curve compared to high-level abstractions like Flink or Spark. And the good part of this one is it's fine-grained controls. Pretty much you can do it over data processing. And if your team is comfortable using low-level APIs, Storm is a best choice for low-level processing. Spark is the same as Flink, where it has a high-level APIs. And if your team is familiar with the Spark systems, it's easy to put it in your Spark ecosystem. It always it's always easier for if you are already in a Spark ecosystem in your organization. And also it provides batch processing APIs. And already, as I said, if a team is familiar with an Spark ecosystem. So the last one, but not the least of a key feature, which is a latency and processing model. Flink is designed for low latency processing, as we said, and supports a sub-second latencies. Okay, that's a you have to understand as I called out here. And in terms of a processing data in event time, offering a precise controls over timestamps-based computations. And but the stringent part is a timing requirement for application, requiring a low latency real-time responses. So Storm is known for low latency processing capabilities, achieving a millisecond level latencies, and it operates on at least once processing a model. But you have to look at our easy of a use, which is runs over low-level API. If your team is comfortable with a low-level API, this is Storm is good at ultra low latency, in, if and it's a real-time analytics and alerts. So Spark processing data in micro batches. Most of you guys might know it, or maybe I'll create a separate Spark one. And just post a comment if you want to learn about Spark. I'm here to catch out that information, and I'll provide you details about a Spark. It's pretty much supports like just like a Flink where it sets near real-time scenarios, and this might not be suitable for uh, really requires ultra low latencies similar to Strom, where you're expecting that. But it has a good scenario where your low latency processing is required, but you have to consider is a slightly higher tolerance for your latency compared to a Flink and a Strom. So as I called out, these are the three criteria which I look at high level, especially if I know the three products are towards a streaming processing happens. But these are three gets on it. But I know in my organization, I did work with a Flink as well as a Spark ecosystem. There are data engineering teams always they use if you're batch based, you're not worried about uh, the high latency, I mean, especially low latency, as well as you're not expecting a real-time data. Always we go for a Spark. But if you're expecting some real-time data, especially we use a Flink, a lot of our data engineering, as well as on information security alerts. I hope you learned something new today, and I'll see you in the next video. Right? And please subscribe to Day One Dev.